Okay, let's begin the recording and let's begin the lab together. So, good afternoon, everyone, and welcome to Lab 6, master file record and master file table calculation. Sorry, master board record and master file table calculation. Okay, so just a second. Good afternoon, Debbie. Thank you. Oh, sorry, guys. Okay, so master boot record. So firstly, we need to calculate this four things. We need to find whether whether that given partition is bootable or not. We need to find different we need to know what type of file system that partition is using, from where that partition will start, and what is the size of the partition. Okay, these are the four important things you need to note. Okay, so foremost thing is you can open this YouTube video and then hit, sorry, once you go through this here in more, you will be able to see this MBR cheat sheet. Okay, so if you go through this MBR cheat sheet, then you'll be able to see the structure of that master file record. Okay, see, here you can see the boot signature. Before that, you can see master boot code. This is the header for this master boot record. And then these are where the partition will start. Okay. And to determine from where the partition will start or from which location partition will end, you always need to go and find for this magical number. Okay, 55AA is the magical number you need to go through. Okay, so in this case also, if you go here you will be able to see that 55AA. Okay, so this is the magical number you need to search for. Okay. So right before this magical number 55AA, your last partition will be there. Okay. So it means that let me make the first partition with this green color. So this is the first partition, and it will be up to this point. Okay, each partition will be 16 bytes. Okay, if you count from here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so next partition will be starting from here, so this will be the next partition, so that will also have 16 bytes. Okay, so sorry, again. So the second partition will start from here. So this will be the second partition, 16 bytes, and the first partition will be from here. Okay, so this will be the starting of the first partition, and then it will go up to this point. Okay, so here before this, okay, I want to explain few of the things for you. So the first thing is one, the size of master boot record is equal to one sector. Okay, so one sector means one sector is equal to 512 bytes. Okay, and another thing you need to note, and another thing is one cluster is equal to 8 sectors. Okay, so these are the important thing you need to note, and the size of master boot record is one sector. It means equal to bytes. Okay, and among these 512 bytes, the 64 bytes means four partitions. Okay, so MBR means master boot record is like a map, okay, to the actual hard disk and actual partition, okay. It will try to find how many partitions are there in that hard disk, and you will be able to see each master boot record will have four partition in our case, and it will be altogether 64 bytes. Okay, means one partition is 16 byte, and altogether, if you calculate, that will be 64 bytes of digits. Okay, that will hold all those partitions. Okay, you can see that one over here as well. So in this case as well, you can see. So if you count from here, that will be 64 bytes. Okay. So now another thing you need to note before we start will be, so how to find, okay, how to find bootable or not, okay. So that is very simple. You go to the first byte of each partition, go to the first bytes of each partition, and if it is 00, then it is non-bootable, okay. But if it is 80, then it is bootable. Okay, so it means if it is 00, it means it is non-bootable. Means if it is bootable, means operating system has been installed. Okay, that is what we what I am trying to say. If it is bootable, means operating system has been installed on that. Okay, now here how to determine whether it is bootable or not. Okay, so here what we need to do first, we need to go to the first one. Okay, this is the header for the first partition. Okay, so sorry, let me use my pen. So this is the header for the first partition. So it means oh sorry, not that one. Mm, okay, it's not working. Try this one. So let me go again. So this will be the header for the first partition. It is 00. Okay, it means it is not bootable. For the second, this is the header. 80 means bootable. For the third, 00 non-bootable. For the fourth, 00 non-bootable. Okay. Sorry. So it means this particular row will determine whether that partition is bootable or not. Okay. So in this case, so first partition is non-bootable, second partition is bootable, third partition is non-bootable, and fourth partition is also non-bootable. Okay. So now another thing is, if you want to find the first one we have already done, the second one is if you want to check, okay, whether what type of file system that particular partition is using. If that is the case, then you have to go to the fifth byte. Okay, so this is where you need to go. So sorry, okay, let me use snipping tool. Let me cut this down. Okay, I've got one message. Do we need to look all the partition, or one partition has 00 would have, means that it is not bootable? Looking like at the PDF, three are non-partition and one is has the partition. No, you have to go through all the partitions. So if you go through this, like here you can see, uh, so first first if we go through this particular partition, so this one, in this case, the first partition 00 is non-bootable. Okay, second one is bootable, third one is non-bootable, fourth one is non-bootable. Okay, so you need to identify which partition is bootable and which partition is not. So in this case, so this and this one is the first partition, this is the second partition, this particular thing is the third partition, and this one is the fourth partition. Okay, so only the second partition is bootable and all other partition are non-bootable. Okay, and this first partition will end at this point. Okay, so first partition will end over here, second partition will end over here, third partition will end over here, and fourth partition will end over here. Okay, so just count 16 bytes. And now if you want to find what type of file system that particular partition is using, you have to go to the fifth byte. Okay, 1 2 3 4 5. Okay, so this fifth byte will determine for the first partition, this is the byte you need to look. Okay, so 07. So 07, if you go to this master file record cheat sheet, you will be able to see over here. Okay, see, 07 means usually we use NTFS file system. Okay, so it means NTFS file system, the first partition has NTFS file system, the second also has same NTFS file system, third also has NTFS file system, but the last one has different file system, that is 0F. Okay, so if you want to identify what type of file system is that, you have to check this cheat sheet and you'll be able to know MS extended partition LBA. Okay, so that is the type of partition we have. Now in order to find the total size, okay, now if you want to find the size of the partition, so how you will be able to find the size of the partition, this is very crucial to note. So here, so last 4 byte of the partition, okay, will determine the actual size of the partition. Okay, for each partition, the last 4 bytes. Okay, so same thing for the third one as well, last 4 bytes for that partition, and last one is also last 4 bytes. Okay, so first one 4 bytes is 00808A. Let me write that. So okay, let me, so what will be the first partition, the size? So this is the size. Okay, that is 00801A and 06. Okay, so what you need to do, these are in hexadecimal form, you need to convert it into decimal. Okay, but before that, first thing you need to do is you need to convert this into little Indians. Okay, why you need to convert it into little Indians? Because when we read this number, we read it from the left hand side. Okay, like we read 1000. Okay, but when system read this number, when we keep this number in the system, it is written in this way. Okay, 0001. Okay, this is the way we write 1000 in the system. So in this case also we have written from this side. When you write something in the system, it is written from the right hand side. So that is little Indian. Okay, so first we need to convert into little Indian, that is 0606, and then 1A, and then after that 80, and after that 00. Okay, so in this way we need to write, and then now we have to convert this into decimal. Okay, for converting this into decimal, this hexadecimal bytes, or you can write in this way as well. Okay, 0x, okay, in that way. And then we need to convert this into decimal. Let's I think directly I can copy this, and you can use any tool, okay, for conversion. Okay, I got one message. Okay, that's great, thank you very much. So yeah, we get this, okay. So the value is, so this is the value, but what will be the unit of this value? Can anyone say what will be the unit for this value? Yeah, whether it is bytes or it is in any other gigabytes. Okay, thank you, Matthews, for the answer, but it is actually not in bytes. Okay, they are in sectors. Okay, so sector or sectors, whatever it is. So how you will be able to know what is that? See here, the total sectors. Okay, so it is calculated in sectors. Okay, not in bytes. So now what we need to do, first thing we need to do is we need to convert this sector into bytes. Okay, so how you'll do that? So for that, equal to 10240000, and then into 51212. Okay, so if you are confused how we got that number, then it's very simple. I'll show you that one as well. Just go and x to decimal, just type this type of thing, and you'll get online tool. Just paste it over here, and once you convert, you'll get this number. Okay, so hex to decimal, just convert that and you'll get this number. Now since this number in hexadecimal, so first thing you need to do is you need to divide, you need to multiply it by 512. Okay, then only you'll get bytes. Okay, so once you get this into bytes, what you need to do is you have to convert this into gigabytes. Okay, so the value will be 48 point something. So how will be dividing that? Okay, that is very important. So first thing you need to know is 1024 bytes is equal to 1 kilobyte, and 1024 KB equal to 1 megabyte, and 1024 MB equal to 1 GB. Okay, so in order to convert this into gigabyte, what you need to do is, so you need to take this number, since it is in bytes. So if you divide once by 1024, it will be in kilobytes. Again, if you divide this whole number by 1024, means this number by, so what you can do is you just keep bracket over here and then just multiply, again divide by 1024, and just again divide it by 1024. Okay, so if you divide this number, so if you divide this number, whatever you get 3 times by 1024, then you'll get in gigabyte. Okay, so that is the answer you'll get. So yeah, this is how we calculate, since we take the size of the partition in terms of gigabytes in your device. Also, if you go through that, then you'll be able to see the size of the partition in gigabytes. Okay, so this is the important thing you need to note, how to convert into gigabytes. Okay, either you can take the help of online tools, or you can change the size. Okay, and then this is how we do. In your lab manual, I think everything is provided, and same thing goes with the location of that particular partition. Okay, to find the memory location of the particular partition, you have to take second last 4 bytes of the partition. Okay, so you have to calculate this second last 4 bytes of the partition, and this particular 4 bytes, if you calculate, it will also be in sector. But in this case, you can, if you want, you can keep it in sectors. Okay, you don't have to convert because the memory location is usually defined in sectors. But if you want to convert into bytes, that is also fine. Okay, so in this case, I think here is some mistake over here. It will be 8000 only. So where is that? So it will be 800. Okay, not 00 over here. So that is one mistake over here. But anyway, so and how to calculate? You can go in this way as well. Okay, 0 to the power 16 to the power 0 plus 16 to the power 1, 16 to the power 2, 16 to the power 3, 4, 5, 6, 7. Okay, this is how you manually calculate these things. Okay, and uh, yeah, finally it will be 480. Okay, 48.82. This is by dividing this entire number 3 times by 102034. Okay, sorry. So any question regarding this first exercise? So let me know if you have any question. How? So I will describe in a brief once again. So this first byte, first this is the header flag for that each partition. Will determine whether it is bootable or not. Okay, the first partition is non-bootable. Second partition is bootable because it is 80. Third partition is non-bootable. It is 00, and fourth partition is also non-bootable. Okay, and in order to find the type of file system, you need to go through this fifth byte counting from the starting of the header, and then you'll be able to see what type of file system is that. Okay, in this case, three are NTFS file system and one is some different file system. Okay, and then after that, if you want to find the size of the partition, last 4 bytes of the partition will determine the size of the partition, and second last 4 bytes will determine the location, okay, where this partition actually exists in the hard disk. Okay, so that are the things. And in order to find from where the partition will start, you need to go through this number 55AA. Okay, all good? Any confusion on this thing?
I just had a quick question. You
Mm-hmm.
said the system ID was 5 bytes in.
Mm-hmm.
When we start counting, do we start at 0 or 1?
No, we start at 1 if you are thinking about 16
Yeah.
bits. So
Uh,
offset is 0. If you take the offset value, let's suppose for this, if this is the partition and if for this is the offset 0. Okay, but
hmm,
bytes is 1, 2, 3, 4, 5, 6, 7, 8. Okay, if you are thinking about offset 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F.
okay.
Okay, so
Uh,
if we are talking about offset, then it will be 0, starting from 0 offset. But if you are thinking about talking about bytes, then it will be starting from 1, because we have to count 16 bytes. This is the first byte, second, and this will be the 16th byte. Okay,
thank you.
no worries. All good? Any other question, guys? If this comes up on the assignment, how accurate would we need to be? with the size, for example. No, you don't have to be that much accurate. Try to provide just two values, 48.8 to something like that. You can do round up as well. 48 should be correct, but point after point, yeah, it doesn't matter much. Does that answer your question, Matthews? No worries. Thank you very much, guys. Okay, let's go with the second exercise. Second exercise is master file table. Okay, so master file table is also very important. So master file table is the each file you store in the database will have master file table. Okay, why it is important as a forensic investigator? Because yeah, as a forensic investigator, so master file table will provide you the metadata of that file. Okay, when that file was created, when that file was modified, when that file was accessed, what type of data that file was storing, maybe the name of that file, what was the name of the file, what was the size of the file. If you want to see all those information and in which memory location that file was actually there, if you want to find all those information, then you have to go through master file table. Okay, so each file, remember one thing, each file will have master file record, and these are the three attributes which you need to identify. So the first one is attribute 80, second one is attribute 30, and the third one is sorry, first one is attribute 10, attribute 30, and attribute 80. Okay, so let me explain few important things about master file record first. Where is my, okay. So in this case, uh, let me, okay, is there any important thing I have missed? Let me, okay, okay, that's fine. So, so now master file record, master file table, okay. Sorry. So master file table is the table, the total capacity of master file table is 2 sector, okay. It means 512 into 2. Okay, so it is equal to 1024 bytes. Okay, so the size of master file record is 1024 bytes. First first 512 bytes will provide you with the information, and second 512 bytes will provide you with the data. Okay, if the size of the file is less than 1 KB. Okay, this is altogether 1 KB. 1024 bytes is also equal to 1 KB. Okay, so if it is less than, the data is less than 1 KB, maybe 512 bytes or something like that, then the master file table also holds the data. Okay, so if it is more than 512 bytes, or 1 KB, let's call it, theoretically it is 1 KB, less more than 1 KB, then that data will be stored in some other location of the memory. Okay, and then because of that you'll get this data run. Okay, so if the actual data is stored in some other location of the memory, then you'll get the data run. Okay, that is because that is why you are getting the data run. So now other important things, let me, okay, so now what else? Master file record. Okay, so attribute 80, attribute 10, so one hex 10. Okay, or attribute, the signature will be 10000000. So this attribute is also known as standard information. So this is a standard information attribute X 30 or 30000000 is a file attribute. So let me give this an RI file attribute, and X 80 or 80000000 will determine data attribute. Okay, so it means, so attribute 10 will always start from this signature number. Okay, 100000, that is what we will be finding, we'll try to find in this lab. So second attribute is attribute 30, that is called file attribute, and the third attribute is attribute 80, which is called data attribute. Okay, so now what we need to do is how to find this first attribute. Okay, how to know in which location the first attribute will be. Okay, that is one question we need to fix. So this is the master file table. Let me use the sniffer tool. Okay, so how to find from where that so how we will be able to know from where this attribute 10 will start. Okay, so for that, the most important thing you need to look is you need to look at this particular value. Okay, so let me clear that. So this means where you need to look is you need to look at offset 14. Okay, see 10. Okay, sorry, that's not very good one. So this is offset 10 and offset 4 is altogether equal to offset 14. Okay, the value on the offset 14 will determine from where that particular first attribute will start. Okay, so in this case it is offset 28. Okay, so 38. Okay, so 38 means you have to go to, here is 30 and you have to go to 8. Okay, so this is 8, so you have to go here and then only this magic number, so 100000 will determine that the starting of the attribute 10. Okay, so let me clear this one. So this will be the starting of the attribute. Okay, so this is how you'll be able to know from where that attribute will start. Okay, so now another thing is there are other few
Can
important
I ask
things.
a question? Sorry.
Yeah.
Why did you start at 14? Like,
Okay. So this is like a syntax. Okay. So from this flag, so by going to this flag x14, so when you go through x14, it will provide you the location attribute. Okay. Every time. Okay. When you go to the x uh, hexadecimal offset 14, it will determine from where the first partition will start. Okay.
okay, so it's
Sorry,
always 14.
yeah, first attribute will start. Okay, yeah. It is offset 14. Okay. See
Okay.
0, 1, 2, 3, 4, and then
Yep. I
10.
was just curious why
Oh
How
yeah,
you got to 14?
yeah,
What,
that's very good question. Yeah, we start from offset 14. So and another one is offset 16. There is another offset called offset 16 over here. This offset 16 will determine whether the file is in use or sorry, file or folder is in use or deleted. Okay, so offset 16 means this offset 16, this particular point will determine, this will determine offset 16, 1, 6 will determine whether the file is in use, folder is in use, or folder or file is deleted. Okay, so by looking at this flag, if it is 0, 0, then file deleted. If 0, 1, file in use. If 0, 2, deleted. Sorry. And if it is 0, 3, use. Okay, so either there will be file or there will be folder. Okay, there will be no more than that. Sorry, Mathis, I didn't get you. What you are trying to say?
I'm sorry, I was just saying to use the 14 is a lot easier to find the location than just looking for the 1000000, like as a find a word sort of thing.
Yeah. So here there will be 4 flags in offset 16, and by looking at those flags, you'll be determined whether the file is in use or file is in use or file is deleted, or folder in use or folder is deleted. Okay, in our case it is folder in use because it is 0, 1. Okay, so in this case the file is in use. Okay, so another thing is only one important thing you need to note now, that is in offset 28. So offset 28 is this flag. So offset 28 will provide you next attribute ID. Okay, so if you look at this point, you'll be able to see 4, offset 28, 20. So if you go all the way here and offset 8, 28 will determine you the ID is 0, 4. Okay, it means that there are 3 attributes, and there will be, if new attribute will be added, that will be the 4th attribute. Okay, so it is clear up to this point. I know it is little bit confusing, so there are lots of things going on. I'll provide you with all those recordings as well, so don't worry. I'm going little bit slow today. Not sure I'll be able to complete everything or not, but I'll include everything in the recordings. Okay. So are you able to understand up to this point what I'm trying to say? So standard attribute. So you need to find this standard attribute, and to find the standard attribute, first you need to go to offset 14, and offset 14, the value of offset 14 will provide you with the location. Okay. And offset 14, if you go to offset 14, it is showing 38, means you need to go to offset 38. Okay, it means 30 is here and 8 is here. In that way, we can find the first attribute, that is standard attribute. Okay, standard attribute information. So, and then other thing is offset 16 will determine you whether the file is being used or it has been deleted. So in this case, file is in use because it is 01. And another thing is, if you go to offset 28, it will show you whether that what will be the next attribute ID. Okay, in this case, if it is next attribute ID is 4, then we have only 3 attributes that is shown over here. Okay, so in your question also you can see there are only 3 attributes: attribute 10, attribute 30, and attribute 80. Okay, so and then yeah, everything is explained over here, but yeah, I'm trying to explain how much I will be able to cover. Now the second thing is, so how to find the size of that attribute? Okay, so size of that attribute is next to bytes. Okay, so next to bytes, the offset 4 and 5th, you can say 1 2 0 1 2 3. So offset 4 and offset 5 will determine the size of the attribute. Okay, for any attribute, if you want to find the attribute, then offset 4 and offset 5 header size of the, so this offset 4 and offset 5 will determine the size of the attribute. Okay, so it means hexadecimal 60. Okay, so offset 60, this particular attribute, first standard attribute information, will end at attribute 60. Okay, so how you can say that? So if you count, this will be the first 10 attributes, second, third, fourth, fifth, 60. Okay, so here the standard attribute information will end. Okay, so this is offset 60. Okay, if you want, you can count with 0 1 2 3 4 5 6 7 8 9 10 9, and A B C D E F. Okay, the first uh, zero standard information is over here. Oh, okay, not over here. It will be 10, 20, 30, 40, 50, 60. Okay, so if you are confused, then what you can do, you can convert this offset 60 into hexadecimal. So hexadecimal bytes into decimal, and then you can count from here. Okay, so it will end at this point. Okay, and then after that, the second attribute will start, that is attribute 30, and the right next to 2 bytes will determine the size of this attribute. It is 78, means offset 78. So this will be offset 10, 20, 30, 40, 50, 60, 70. And if you go all the way to this point, once again, so this will be offset 10, 20, 30, 40, 50, 60, 70, and you have to go all the way to other 878 offset, and then finally it will end over here, and the new attribute, the data attribute, will start from here. Okay, so this will be the starting of the data attribute, and this will be the size of data attribute. Okay, so size is 60, hexadecimal 60. It means 10, 20, 30, 40, 50, 60. Okay, it means it will end over here. Okay, and then, so when you encounter this FFFF, it means this is the end of the first 512 bytes of your master file table. Okay, So what you need to do, you just write right after this standard attribute information, you'll get the size of the standard attribute information. Offset 60 means you need to count 10, 20, 30, 40, 50, 60. It will end over here. And offset 30 means, then the file attribute information will start from here. This is 30000000. This is the signature for that file attribute. And offset 78 will determine the size of this particular file attribute. So this will be 10, 20, 30, 40, 50, 60, 70, and we need to go offset 78. Okay, we need to count 8 as well, then 78 will be here. Or you can convert this 78 into decimal, it will be 96. You can count from here till 96, okay, all the way to 96, and then here it will end. And then again, for data attribute, you'll be able to see 80 and then 00, and then you can see the size. Okay, so is this clear up to this point? Guys, any confusion at this point? Okay, thank you very much. Thank you, Andrew, for verifying that. Okay, now what we need to find, only the thing we need to find is date and time. Okay, date and time for, okay, so here I'll write few more informations. So, okay. Okay, thank you, Devi. Let me write few of the things. So what we are trying to do is we are trying to find the uh, date and time. Okay, so to find the date and time, what you need to do is there are two ways to take. Either what you can consider is after first 24 bytes, not the offset. Okay, after first 24 bytes, the starting first 8 bytes will be the file creation date and time. Okay, so here that is 25th. Okay, from the, sorry, CREATION. So the 25th byte will determine the starting of the file creation. Okay, so it means that from starting from 25th byte, let me clear this. It's a little bit. Okay, let me. Oh, sorry, that's fine. So this will be the 25th byte. Okay, so this first 8 byte will determine the date and time. Okay, file creation date and time. Okay, this 8 byte will determine file modification date and time. Okay, this byte will modify uh, metadata access date and time, and this 8 byte will determine the last time file access date and time. Okay, once again. So this is, so how to calculate this? Okay, how to find date and time, that what I want to show you now. So for finding the date and time, so of the file creation, for this one, you have to use this decode tool. Okay, decode tool is over here. If you go to your lab manual, okay, I think at the starting, where is that? Okay, here you'll be able to see that. So this is the link you need to go through, master file table. If you go through this link, open that link, and if you go all the way down, then somewhere you'll be able to see this decode download. Okay, just you need to click on this. There will be a zip file. So just install that in your system, and you should be able to run this decode tool. Okay, so running that decode tool, so just double click on that. Okay, this is the decode tool, how it looks like. So now what we need to do is we just need to convert this first. I need to find the date and time for the file creation. Okay, file creation date and time. So for that, let's keep the value. And in this case, it will already decode it into little indents. Okay, so you don't have to write from right to left. Okay, in this case, just keep the values. CA, D8, A5, 6B, and 0B, 57, C5, and 01. Okay, and there is one important thing you need to note. If the date and time has not been adjusted to Canberra, Melbourne, Sydney, then you need to adjust the time, but by default I think this will be the time for you. And then what you need to do, just only the thing you need to do is just click on decode. Okay, once you click on decode, then this will be the date and time we'll be looking for. Okay, maybe I need to change. Okay, let me decode once again. 30. So this will be the date and time we'll be looking for. Okay, Friday 2005 5:13, and this is the time. Okay, so we're looking for the date and time. You can change this one as well. So minute, time, so that's up to you. So this will be the time we'll be looking for. Okay, since it is a master file table is of Windows operating system, so we'll be looking at the Windows time. Okay, so if it was the something like from the if the master file table was taken, that metadata was taken from the Apple or the Mac, then you'll be using those times, and other thing, Unix OS, then other thing. But this time we'll be using this Windows file time. Okay, this is what you'll be getting. So this is how you convert. Okay, just provide the value and it will throw you with the date and time. Okay, so any confusion on this one? So same thing. Okay, so same thing will be there for your attribute 30 as well. So this is the starting of the attribute 30, and this will be the size. And then to find the date and time, for this case, we went through first 24 bytes. Okay, but in this case, it will be after first 32 bytes. Okay, because one of this 8 byte will carry the information about the parents data. Okay, so we have to go to only first, so we have to eliminate that first 8 byte, one of the 8 bytes. So if you count first 32 byte from here, the date and time will start. Okay, so in this case, but date and time will be same as the date and time of the file creation. Okay, in this case, the reason behind that is, so all the file creation date and time, this is file modification date and time, this is metadata access date and time, and finally this one is the last time file access date and time. Okay, this one is the last access file date and time, but all those date and time are same. The reason behind that is this file has not been accessed. Okay, means that file just created and then just left as it is. Okay, so because of that, all those date and time are same. Okay, but in this case, although the file has been created and not used, but they have accessed those metadata information and those things because it is standard attribute information, means the metadata of the file or property of the file has been accessed. So because of that, you will be able to see the change in the dates. Okay, so okay, it's already 202. Do you want me to explain? Can I take your 10 more minutes, or what do you say? I'll just do the recording and send you the rest. If you want, I can take 10 more 10-15 more minutes. It's up to you. Okay, if you guys are busy, then other thing. Otherwise, yeah, I can go furthermore.
Will you have a recording of the rest of the session or?
Yeah, I'll provide the recording of remaining the things as well.
Okay, thank you.
So you guys want to wait or you want to leave? I need answers. Okay, if you need to go, it's too bad. Okay, then that's fine, guys. What I'll do is I'll stop this over here, and I will continue the recording from here, and then I'll post it. Uh, okay, let's continue from where we have left before. So as we have already discussed about attribute 10 and how to find attribute 10, it's already over here. Now let's discuss about attribute 80. Same as attribute 10, the first 4 bytes determine the signature of the attributes, and after that byte 5 and 6 determine the size of the size of the attribute. So here, so you can see first 4 byte determine the signature of the attribute 80. So it is file attribute. Okay, and then after that 2 bytes will determine the size of the attribute 78. Either you convert that 78 into decimal form and then start counting, or you can consider this as a 10 bytes. So 0, 1, 2, 3, 4, 5, 6, 7. Let me zoom out a little bit. So 7, 8, 9, 10, 9, A, B, C, D, E, F. So these are 10 hexadecimal bytes. If you convert 10 hexadecimal, then the decimal digits will be 16. So 10, 20, 30, 40, 50, 60, 70. And since it is 78 hexadecimal offset, then you have to count 8 from here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So it is altogether 78 hexadecimal. And just a second. So, okay. So now the other thing is the eighth, ninth attribute. So 1, 2, 3, 4, 5, 6, 7, 8. Ninth byte will determine whether it is file is residence or non-residence. Okay. So in this case, wait, I have written something wrong. So ninth byte, since it is 00, residence. So it means that info is inside master file table. So these are the things now. Now what will happen is, in this case, the date is starting from, so if you count this 8, 16, 24, 32, the only is starting from 33rd byte. Okay, so 33rd byte, not hexadecimal, simple 33rd byte. Okay, the reason behind that is, so here one of the 8 bit is, let us suppose this 8 bit carries the parent's information. Okay, parent's information. Okay, so because of that, so this 8 bit is ignored, and then only after that, so this is the, let me zoom out a little bit. Okay, so this will be the file creation date and time. After that, file modification date and time, file change date and time, and then last access date and time. Okay, so all, but here if you see closely, as I have already discussed, all those date and time are identical. Okay, see the sorry. Hmm. So it means that the file creation date and time, file modification date and time, the metadata access date and time, and file change date and time, all those date and time are identical. The reason behind that is the file was never been accessed once it is created. Okay, so that's the reason. And again, if you want to uh, uh, calculate how to determine how to find date and time, so it's very simple. So just open this particular application. So among them, one of 8 parents information. Okay, so 43rd byte will start file access. Okay. So file access date and time. So from here also you can determine like so this is the application. What is that? So this first 8 bytes from the 33rd byte will be the file creation date and time. Okay. So this is, sorry, this is file creation. This second one is file modification. This third one is metadata access date and time. And the fourth one, the last one is last time file accessed. Okay. Date and time. So similarly, this 8 bytes refer to the parent information, and then this particular 9th byte will represent, in this case it is residence. Okay, so these are the information you need to know. So now let's calculate this information and let's see. So what will be the date and time? Date and time will be same. Again, I am calculating. And since already it is in Little Indian, so when we convert whatever it is, hexadecimal form into decimal, in that scenario, we need to convert it into Little Indian. So whatever calculation we are doing, first we need to convert hexadecimal bytes into Little Indian. But in this case, we are not converting it into Little Indian when we are using this application. Okay, the application is decode. The reason behind that is decode already has the functionality. When you are taking this hexadecimal form, before it convert into date and time, it already first it convert into Little Indian, and then only it will convert, then it will transform this hexadecimal bytes into date and time. So for that reason, you don't have to convert into Little Indians. Okay, so that is CA D, this one D8, and then A5 6B 0B 57 C5 and 01. Okay, so now when you write this value, just need to decode that. Once you hit on decode, sorry, here are few things you need to consider, like the time zone should be Canberra, Melbourne, Sydney date and time. So if it is not, then you need to adjust the time. Okay, this is very important, the time thing. Like
I think you got the example in your class as well in the lecture. So, and we have discussed that in the lab as well. Okay, if the time zone is different, then the evidence will not be verified. Okay, and I hope you have heard about the case where because of time difference, the case that evidence was not being accepted by the court. Okay, so for that reason, uh, time and date thing is very important. So, and finally, since it is a Windows based time, so we'll take this Windows time, okay? And then I think by default it is something I'm not sure which will be. Even you can take this one as well. Decode, it doesn't make any difference. Okay. So this is the time 1301 and all those time will be same in this case. So you have to consider this Windows file time. Okay, just ignore every other time, Apple time, Chrome time, Microsoft Teams and other thing, Unix time, because the master file record is taken from Windows based operating system and we are taking the UTC plus 10 time, not only UTC. So plus 10 means our Canberra, Melbourne, and Sydney time. Okay, so this is the thing we need to consider. Now, after this thing, so other important thing is you need to identify the name of the file. Okay, so if you go here, see the name of the file is pictures.zip file. Let me zoom out a little bit and see here the name of the file is pictures.zip file. Let me highlight that one. So this is the name of the file. Okay, so from where to start to calculate the name, to find the name of the file? So the starting point will be this particular uh, hexabyte. So every time this hexabyte will determine the starting of the name of the file. Okay, and sorry, not the name of the file. So it will determine how many bytes how many bytes will the file name have. Okay, so in this case, so C means 12 bytes. So from here also you can count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you need to consider this decimal points as well. Okay, so there are altogether 12 bytes in that file name. So just ignore this flag. This flag represent something else. And then after that, so this will be the first byte, second byte, just a second. So second byte, third byte, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So these are the bytes, okay? So now, and what you need to do, you need to ignore those 00, okay? Because yeah, it doesn't carries any values 00. So just ignore all those 00 and then if you convert them first into decimal, and then if you convert them into the hexa, sorry, into first convert it into decimal and then convert them into the ASCII code, then you'll be able to find those file name. Okay, so here is also the solution. If you go to this point, see the name of the file is picture.zip file, and they have also taken starting from 50, 69, 63, 74, 75, 72, 65, 73, 2E, 7A, 69, 70. Okay, so so if you convert 50 into decimal, it should be 80. Okay, see, uh, hexa to decimal. Okay, what happened? So let me take this one. Let's ignore the history. So now if you convert 50 to decimal, then it will be 80. So now convert this 80, so decimal to ASCII. ASCII conversion. It's already, so if you use this rapid table ASCII hexadecimal, then it would have been easy. But anyway, 80. So if you convert 80, so hexa 50 will be decimal 80, and then it is P. Okay, so the first one is P, and we can go with the file as well. Sorry, not this one. So 69. So if you type 69 over here, decimal will be 105 and I, small I. Okay, so in that way, sorry, just this. So in this way, you can use this website as well. So rapidtable.com conversion ASCII hexadecimal. So whatever you convert, let's take one more example. This one, okay. So converting 2E into dot. Okay, so just write 2E over here, and then see 46 will be decimal, and then hexadecimal will be 2E. Okay, so this is how you can convert. Okay, so once you convert, you'll get this name. Okay, you'll get that name, pictures.zip file. And for calculating the size, so 78, if you convert 78 into decimal, so hexadecimal 78 into decimal, then it will be 128 bytes. Okay, and last created date and time, last modified date and time, last access date and time, all those things we have already calculated. So this is the date and time for the records. Okay, all those things, and plus 10 for Sydney, Melbourne date and time. Starting position of short name are the, so in this case there are two type of offsets, short name and long name. So short name is for if there are two file name, then one will be short name and another one will be long name. Okay, So that is the thing, but in this case, we don't have anything like that. Okay. So if there is offset 80 starting from, so again, if it is offset 30 and then same thing, you look at the size and then 00 will be non-residence. And in case of long name, you have to consider another thing that is, so this is file is residence, so it means the information lies inside this particular master file record. Okay, this is not the master file record which we have, so this is for just for the educational purpose. And if there was another date and time, creation date and time for that file, and if you have that file name, then something.txt, then in this case, the date and time will start like right after first 24 bytes, because the information related to the parent directory will be covered on the first part. Okay, so you don't, again, you don't have to consider that the information related to file names. But in this case, in our case, in our master file record, we don't have that. Okay, we just have the one file name, pictures.zip file, and then as soon as that attribute 30, the file attribute is ended, then we have the last attribute, that is attribute 80, so which will start from signature 80000000, and the size of that is 60 bytes. Okay, see here, so first 10 bytes, first 20 bytes, 30 bytes, 40 bytes, 50 bytes, and for 60 hexadecimal bytes. Okay, offset 60, you can consider it as offset 60 as well. Okay, it means here it will be, this will be offset 0 0, this will be offset 1 0, this will be offset 2 0, this will be offset 3 0, and this will be offset 4 0, and this will be offset 5 0, and this will be offset 6 0. Okay, so it means when you start from here, if it is offset 6 0, means when you come to this point, this hexadecimal 80 will be over. Okay, so it means this FF is the end of your attributes. Okay, all the attributes will end at FF. So it means that, so okay, don't be confused. If you count offset 60 means, so it will end over here. Okay, so that is the thing. The offset will let me see, I don't know which color, but anyway, that's fine. So offset will end over here, but now what we need to do is in offset 80, since if we go to the ninth attribute, we can see that this 0 1 means, so in offset 80, so if you go to the ninth attribute, since it is 0 1, it is non-residence. Okay, so this is data attribute, attribute 80 is data attribute, and since since the ninth byte is 01, non-residence means information related to actual data is outside MFT. Okay, so actual information related to data is not inside master file record. So because of that, since the data information is not inside master file record, so we will have, so this will result in, this will result in data runs, and the size of the file will be mm, size of the file is more than 1 KB. Okay, this is theoretical. So in theory, since master file table is just of 1 kilobyte, if the size of the file is more than 1 kilobyte, then you'll have a data run, and those information will be saved in some other location of the memory. Okay, so in this case also same thing. So since it is non-residence, so you'll have a data run, and then all those information will be saved within the memory hard disk, but it is somewhere outside master file record. But all the information related to the memory location, the size of the data byte will be, all those information will be inside master file table. Okay, so all those metadata information will be inside this master file table, and now you need to know from where the master file, the data run will start. Okay, so for that, the first thing is you have to go to this flag. Okay, so this particular byte, so either you can consider it as offset 20, so that is one thing. So offset 0 0 f 1 f and then 20. Okay, either you consider it as offset 20 or the 33rd byte. Okay, either you consider it as offset 20 offset 0x, sorry, 0x 20 or 33rd byte flag where the runs will start. Okay, so this data run will depend on the size of the size of the file. Okay, or the size of the data. Okay, if the size of the data is very high, then there will be lots of data runs, and if the size of the file is small, then there will be less number of data runs. Okay, so in this case, let's go back to the data run and let's see. So since this flag will determine, in this flag, the name, the hexadecimal byte is 40. Okay, means from offset 40, means this, from offset 40 the data run will start. Okay, in this case you can consider as this from here, this offset will be here, it will be, so here this will be, no, let me make it black, 0f, and this offset will be 1F, this will be 2F, this will be 3F, and after that this is 40 offset. Okay, so it means this is offset 40 will start from this 31. Okay, so I hope you understood what I am trying to say. So the first offset is 0F, 1F, 2F, 3F, because it is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this will be A. Okay, this will be B, C, D, E. Oh, sorry, I think I missed. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then after 9, so then only you'll have A, B, C, D, E, F. Okay. So offset 40 means 31 will be the first cluster. Okay, so sorry, first data run. So here offset 40, so what 0, and value is 31. Okay, so this 31, now let's 31, let me divide this 31 into two parts. One is 3 and another one is 1. Okay, so 3 is called maximum nibble and 1 is called minimum, sorry, minimum nibble. Okay, so 3 is maximum nibble, which will determine the location of the memory where cluster or data will start, and minimum nibble will provide you size of the cluster means size of the data. Okay, so now if you see 3 means, so you have to take a minimum nibble first. So minimum nibble means, so since minimum nibble is 1, so you have to take first byte after data runs. This will be the size of the file in cluster. Okay. And since maximum nibble is 3, means you have to take after this first byte, you have to take other 3 bytes. Okay. So what does that mean is, I'll show you. So as soon as you see this data run, so this first, so minimum nibble, so first byte means this one. Sorry, let me take the pen. So this byte will determine the size of the cluster, and this, since the maximum nibble is 3, means 1, 2, and 3. Okay, so these 3 bytes will determine the size of the cluster. Okay, so what you have to do, so if you consider this, so this one is in cluster. Okay, 0, 5. So first byte if you consider, so the size of the cluster is means 0, 5. It means since it is in cluster, 5 into, so if first you need to convert this into a little Indian and then convert it into decimal. Okay, so decimal also will be 0, 5, since hexadecimal 0, 5 is same as decimal 0, 5. If you are consider again, you can convert that 0, 5 into decimal. So if you convert also, the decimal value will be 5. Okay, but this value is in cluster. Okay, cluster, first convert it into bytes, so that is 0, 5 into 8, since one cluster is 8 segments. Sorry, not the segment, sectors, and then again convert this sector into bytes into 8, and each sector is 512 bytes. Okay, so now this will come back to bytes. This the segment, one size of the size of the data run, or the data which is stored in some other location of the memory, will have this size in bytes. Okay, now you can divide it by, so if you see this, once it is in bytes, then if you divide it by 1024, then it will be kilobytes, then again 1024, then it will be megabytes, and then again if it is 1024, then it will be in gigabytes. Okay, so this is how you can convert. First it is in cluster into sectors, because one cluster will be equal to 8 sectors. Okay, and then after sectors, convert it into decimal form, sorry, convert it into bytes, and then again, if you want to convert it into megabytes or kilobytes, it's up to you. You need to divide it. Okay, so in this maximum nibble side, In maximum nibble side, first you can see so this will be the cluster size, and this 3 will be the nibble. Sorry, the location from where that data segments will start. Okay, 5A E700. So that is 5A E700. What's going on? Okay, let me. Okay, now in this case, let me see. Okay, that's fine. So that is 5A7E00, 5A7E00. First convert them into Little Indian. So it will be first it will start at 00. So write 00 7E and 5A. Okay, 5A. So now this 7E 5A, copy this, convert them into decimal. So once you convert them, the value in the decimal will be 32,346. So two, three, four, six, I guess. Cluster. Okay, you can leave it in cluster because the size of the memory location, like from where this particular one data byte, like the value of the minimum nibble is 1 byte. So it means that this will be the size of the data, which will start from this memory location. Okay, this cluster, or you can convert them cluster into sectors first. So it means into 8, divide it by multiply it by into 8, then that will be the size in sector. Okay, sector, or you can leave as it is in the form of cluster as well. Okay, so that's fine for the memory location. So now, okay, let me remove this one. So now once the first data byte finish, second data byte. So 2 1 means the minimum nibble will determine the size of the cluster, means this one will be the size of the cluster 0 6, and the maximum nibble will determine the memory location from where that cluster will start. Okay, same thing in this case, and this will be this 2 bytes. Okay, since the maximum nibble is 2, again the now new data run will start. 1 1 means the minimum nibble and maximum nibble is 1. So the data, so this, sorry, let me- so this is the data byte, and this will be the memory location, okay, from where the data byte will start. Now again, new one will be, next data run will be 21. So same thing, the minimum nibble will be 1. So the data is 24 cluster, and the maximum nibble is 2. So it means that there will be, we have to take 2 hexadecimal byte. Okay, that will determine the size of the cluster. Okay, so same thing. Now after that we have new cluster, that is 21. So 21 means the minimum nibble is 1. So this will be the size of the cluster, and this will be the data run. Okay, since it is 2 again. So next data run will start at this point, that is 21. So it means the first data run, sorry, the first byte will determine the size of the data run, and the next byte, sorry, let me clear a little bit over here. It's like a little bit crowded. Okay, so again, so this will determine the next data run. So 0b is the size of the data run, size of the cluster, and then the maximum nibble is 2, means 2 will determine the from where that data run will start. Okay, again 21. So next data run is this 21, and the first byte, since it is only 1 byte, so this will be the cluster size, size of the cluster, or the size of the file, and the next one will be the, since the maximum nibble is 2, so the length of the data run. Okay, and finally when you encounter this the byte 0 0, means here will be the, so here this will be the end of data run. Okay, so here once again, since the minimum nibble is 1, so this will be the length of the data segment, and this maximum nibble is 3. So the size of the from which memory location the data run will start. Okay, same here, minimum nibble is 1, so this will be the size of the cluster, and from where that cluster will start will be over here, okay, since it is maximum nibble is 2, okay. Same thing here, the maximum nibble and minimum nibble are 1 1, so this will be the size of the data run, or the size of the cluster, and the memory location from where that data run will start, okay. Same thing here, minimum nibble is 1, so this will be the size of the cluster, and the maximum nibble is 2, so will be the memory location from where the data run will start, okay. So same thing, 2 and 1. So 1 will determine the size of the cluster, and 2 will determine from where the data run will start, okay. So again, minimum nibble is 1, so it will determine the size of the cluster, and this will determine from where the cluster will start. And as soon as you encounter 0 0, this means this is the end of the cluster. And finally, here this FF will determine the end of the attributes, okay. So end of the data run we can consider in any way, okay. So these are the things. Now as I have provided you how to calculate as well, but there are few other things to note. So it's already there in your lab manual. So if you go a little bit down, let me zoom out a little bit, and then if you go all the way down in attribute 80, so don't be worried about this one. This is other different example to make you understand. So this is not the part of the data run which we have provided here, but this is how you can learn, okay, the from where the data run can start. Here also it is same, attribute 80 has started from this point 800000, and 60 will be the size of the data run in this case as well. That will be, it means 10 20 30 40 50 60. So data run will end it over here. You can see FF will be the end of that particular data attribute, okay. And then you can see from here also 10, so 0F, 1F, 2F, 3F, and 40 at offset 40 will determine from where the data run will start, okay. Okay, so here 3 2, sorry, here so let me clear this one. Okay, so it is showing, what is the value of n, what it is saying. Okay, there are a few mistakes over here. So n, where is the n? Okay, so let me, okay, so here in this case, sorry, I made few mistakes over here, not mistakes. So here in this case, so again offset 40, offset 20 will be the offset 20 will determine from where the data run will start. In this case also it is same. The size of offset 20 is 4040, okay. It means the offset 40 will be starting of the data run. It means that the data run will start from here. This will be the offset 40, that means 32, means first two bytes will determine the size of the cluster, and since the maximum nibble is 3, the second 3 bytes will determine the size of the location of the memory from where this particular data run will start. Okay, sorry, this information will start. Same thing, the second data run is 22, means the cluster will be of 2 bytes, and then the size of the data run also will be of 2 bytes. Okay, once again 32 means the size of the cluster is 2 bytes, and the that cluster from where it will start will be 3 bytes, because the maximum nibble is 3. Okay, again 22 means the this will be the size of the cluster, or the size of the data, the first 2 bytes, and the second 2 bytes will determine from where that cluster or that data run will start, or from which location of the memory this the particular information will start. Okay, again 2 1 means the first 1 byte will determine the size of the cluster, and second 2 bytes will determine the from where that data run will start. 2 2, so same thing, 2 2 means the size of the cluster, and uh, the second 2 bytes means the maximum nibble is 2, so second 2 bytes will determine from where that data run will start. Okay, so this is another thing. So always go to offset 20, or you count the first 33rd byte, that particular flag will determine from where the data run will start. Okay, so that is the thing. So it is actually just to give you some heads up, some information. So this is not the part of our uh, actual master file table. Okay, but the information which has been provided over here is part of your MFT, master file table. So where the size of your data attribute, the value of data attribute, the size of data attribute is hexadecimal 60, which is 96 in decimal. So it is in bytes. Okay, so 96 in hexadecimal, because these each are in bytes. Okay, so means the size will be in bytes, but when you consider this bytes in form of data run, that will be in cluster. Okay, so here also you can see first data run, first of the starting of the residence data run will be from offset 40. Since it is 0 1, so it is non-residence file, and then the first data run here you can see the data run 1 31, means 3 will be the maximum nibble and 1 will be the minimum nibble. So the size of the cluster is 5. See, 5 clusters, 0 5. So it will be, if you convert this into first into little Indian and then convert it into the decimal, that will be 5. Okay, and the size of the height is cluster. So here you can see all those informations. So whatever we have calculated, so you can see 31 is the first data run, 21 is the second data run, 11 is the third data run, 21 is the fourth data run, fifth and sixth. Okay, so finally at 0 0 the data run will end. Okay, this second components, or whatever you call it, these are the actual size of the data. Actual size of the data is over here, and these are the memory location from where that data will start. Okay, data run will start. and you can see the bytes. So these bytes are the memory location size bytes. So in this case, it is 8, 16, 24. So it is 24 over here. So the memory location 8 to the 16 bytes from where that data run will start. So it is 16. So here only 8, and here again 16. Again it is 16, and finally again it is 16. Okay, so in this way, so this is from where the uh, the data run will start in that memory location. Okay, and the size of the memory location here you can see in we are taking 24 bytes, 16 bytes, 8 bytes. Okay, so the size of the cluster calculation information is over here. So 5 means 5, 6 means 6, 6, 24 if you convert it into hexadecimal. So if you convert this 24 into decimal, then it will be 36. Okay, so 36 cluster size for the third data run. Okay, 36, and then B means 10 means A, 11 means B. Okay, so if you convert into decimal all those cluster or the size of data, okay, this is data size. Okay, this is data size, and now the location of the memory location to start the memory location. So first we need to convert them into little Indians. So this 5A E700. Let me see whether we have already converted them into little Indians or not. So the first bytes 5A E700, 5A E700. Where is that? 5A E700. So this is not the little Indian thing. So here it has been converted into little Indian. Okay, see first 5A. So 00 E7 and 5A. So 5A E700. Now here it has been converted into little Indian. So here little Indian conversion, little Indian conversion has been done over here, and finally it has been converted into decimal. Okay, so it has been first it has been converted into this little Indian, the hexadecimal form of little Indian, and then so you can see 9068. Okay, in that way. So first 48 and then 51. Okay, so 5A7E00. So see 5A7E00. Now first 00 here, and then 7E, and then 5A. This is how you convert it into little Indian. That is what it has been done over here. See 00, 00, and 7E and 5A. Okay, this is how we write in hexadecimal form. And then if you convert this E7 5A, E7 5A, if you convert that, then you'll get this value, decimal value. Okay, 59,226. Okay, so I think that will be the value 59,226. Okay, so in this case, this will be the this will be the starting location of your memory. Okay, After that, the the size of the memory will start from there, and you have to add new memory size. Okay, so new memory location, so that actual memory location for that next cluster will start from this 59482. Okay, after adding that, so 16, again you have to add 16 for this new cluster 6. So the new cluster will start from 59498. Okay, plus if you do plus in this 482 59482, then it will be 59498. Okay, but in this case, why it is 30930? Okay, in place of adding this number, in place of this BNC offset, you can write LCN offset as well. Okay, so here why we are subtracting 36,968 from 59,498, in place of adding that, the calculation is over here. Okay, why we are subtracting? So for that you have to go to little bit down. So let me where is that? So if you go a little bit down, you'll be able to see the most important information is over here. Let me clear this. So most important information is over here. So like, okay, let me. So offset side, depending on the offset size, 1, 2, 3, and we have to consider this sign range, and then depending on the sign range, we have to calculate the value. Okay, so if it is 1 byte, let me consider if it is okay, sorry. So what is this 1 byte, 2 byte, and 3 bytes? Okay, so what is this 1 byte, 2 bytes, and 3 byte offset size? Means so these are the offset size. Okay, these are the offset size. So these are the offset size. Okay, so in this case it is 1, 2, 3 bytes. Okay, 2 bytes, 1 byte, 2 bytes, 2 bytes, 2 bytes. Okay, so for the first we don't do anything, we just write the starting cluster. Okay, now after that, for finding the second starting cluster of second starting memory location for this cluster 06, we have to consider this particular. So for second cluster will start from this memory location. Okay, that is 0010. So that is 2 bytes. Okay, so if you go here, so in this case, if it is 2 bytes, so just consider this one. If the value is greater than 32,768, then you need to subtract. Okay, so is the value that what is our value? In this case, our value is just 256. Okay, so we don't have to subtract, because that 256 doesn't fall in this range. Okay, 256 doesn't fall under this range that is greater than or equal to 32,768. So you don't have to do anything, you just have to add. Okay, so same thing goes for the next one as well. Next cluster 8 byte, and the value is just 16. Okay, 16 means a 1 byte, 1 byte. If it is 1 byte, then if the value is greater than or equal to 128, then only we need to subtract it by 256. But in this case, the value is just 16. So LNC or VNC offset is just 16. We haven't done anything, and then you just can add that. Okay. But in this case, in this the fourth data run, the size of the cluster from where the memory run will start is 16 bytes, means 16 bits means 2 byte. Okay, so 2 bytes, and when you calculate that the starting location of the cluster, it is 36,968. Okay, it is 36,000 plus, and if it is 2 bytes and if it is greater than 32,768, then you need to subtract it by 65,536. So since it made this range where the starting fourth cluster made this range, so what we need to do here in this case, we need to subtract this particular value or the memory location from where this 36 cluster will start. The 36 cluster data information will start. We need to subtract it by 65,536. It is negative 28,536. So because of that, we need to subtract 59,000. We need to add this. Okay, actually we are adding 59,496 plus minus 28,568. Okay, if you do that, the size will be this 3930. Okay, so this will be the starting cluster from where this data run, this particular data will be stored in that memory location. Okay, now again 2 bytes of data, and the value is 18,513, which is less than 32,000 something. So just the starting cluster for this data will be 49,433 by adding 18,513 on 30,000. Okay, and then again 2 bytes of data, 16 bits, and it is greater than 32,700 something. So what you need to do, if it is greater than 32,700 something, then you need to subtract it by 65,536, and the final value will be 21,429. And once you add that, so with 49,443, then finally you'll get this value. Okay, so this is how we find the starting cluster for each data run or the data that has been stored in the memory. Okay, so first data run will start from here, second data run from here, third data run, fourth data run, fifth and sixth data run. Okay, that is what it is being done. This is very important, so make a note on this one. And finally, other thing, I'll just, you have to first convert it into Little Indian and then other informations. Okay, so this is how we calculate. I hope this makes a little bit of sense. So thank you very much for listening this particular lecture lab recording. And then yeah, there, yeah, it seems to be a little bit of lengthy, but I hope this will help you. Okay, and see you in the class in the next week. Please try to go through the second assignment as well. And if you don't understand anything, please email me. I'll try to provide you with the answers. Thank you very much, and see you in the class.